So welcome back, ladies and gentlemen. We're actually going to be looking at example 1 from the stretches of functions handout. And as you can see, I kind of reproduced this for you, the drawing. So if you need to pause the video, feel free to. But a lot of you realize they actually gave you the critical points of the x's and y's. The first one is negative 4, 2, which is this point. The next one is 0 and negative 1, which is this point. Then we got 4, 1, which is this point. And last one is 6 and negative 3. Now, on a test, if you do this incorrect, you're going to have a rough time. I tend to recommend that you go from left to right or right to left. It does not matter. But being carefully how it's laid is important. Now, some students would argue, but Mr. Chen, what's this point? And you're looking at the screen here. Notice that is a critical point, but you know what? It's easier to see the ends. And the reason why some students actually understand this is because the connection is to facial recognition software, right? Or the CGI when people actually want to do it. They take nice critical parts where your eyebrows are, your eyes, your nostrils, where your mouth is. For example, my mouth is on my neck. That'd be a little creepy. If my ears were on my head or my foot, that'd be weird, right? If my arm is my leg and my leg is my arm, that would be really, really creepy. Mr. Chen, what the hell's wrong with you? Maybe you're mutating. Go away. Oh, crap. Anyways, what we're going to be doing is actually example 1a. Example 1a is as follows. Y is equal to 3 f at x. Now I know some people from the day class right now is getting tired, but let me ask the class this, and I give you guys a hint. Is this 3 an A, a K, a D, or a C? Take your time. It's really easy. If you're not too sure, it's okay. This is the hardest part because on a test, it won't be laid out pretty clear. It is an A. And specifically what this means, and I like writing this out initially when I teach it, this is clearly a vertical stretch by a factor of 3. So some students will start working right away with what I'm going to do. But I'm going to teach you actually a new method. It is actually in here, and it's actually called a mapping technique. Now, I will summarize this, but for teaching purposes, I want to go slow so people can absorb it. And after a while, we can speed it up with the formula. Okay? The formula actually helps. Some students just want to get the answer, but I think you'll be okay what I'm going to do. That's why they gave you some space, and technically, I like doing it this way, although there's some room there. Notice what we're going to do. The vertical stretches, or compressions, they only affect y coordinates. They don't affect the x coordinates. So notice when we perform this transformation of the function, this 3 does not affect the x's. So what are the x's? They're still negative 4, 0, 4, and 6. And I like doing it that way, this portion. Now, after I get the answers, some of you will understand what I'm trying to do. Is that this y value, this negative 4, 2, it's going to be affected by that factor of 3. What does that really mean, factor? It means to multiply. This math tends to be pretty easy. 2 times 3? 6. So this new point will be negative 4, and I apologize, it's easier on your graph. So if you're doing this at home, or you're using your handout right now in class, that point is now way up here. Now we're going to pause for a second. When students actually see this, that negative 4 and 6, they say, Mr. Chen, you crazy, Mr. Chen. That looks like a shift. And so that's why stretches are a little bit different. I'll explain in a moment because I think some of you are slowly getting clued in. With one point, one transformation, sure, it does look like a shift or a translation. It does. But we got to keep on going. This negative 1 times 3, can someone help me out from the class? No pressure. Claire. Nicely done. And again, it's really showing you what you're supposed to do. 3 times that y value. 3 times negative 1. So it's negative 3. And plot it down. And that's what we got for this transformation. This point, 0, negative 1, went down to 0 and negative 3. And again, I do apologize. If you're at home or you're doing this now in class, all you have to do is just plot the points, right? But I'm trying to do this slowly so you learn. And then you can actually do it relatively quickly. So it's a steep learning curve. The next one is going to be 4 and 1. This is speeded up. 1 times 3, that's 3. So we're going to take this 4, 1, and it's going to go up here to 3. And finally, notice this 6 and negative 3 point, this point down here. This -3 is going to be multiplied by 3, and then what do we get? -9. Now let's just pause for a second before we actually connect the dots. One more time. With all these types of transformations, we should get something that looks very similar. Not exact, because this is not a translation. I use the analogy again of shifting up and down. For example, a lot of you understand, if I shift right, just pretend it's still the same. If I shift left, I still look the same. If I shift up, I can't float. If I were to float up, I'm still the same. If I still go down into the ground, into 320, just pretend it's still the same. Shifts don't change. It's the stretches that are weird. In fact, a lot of you understand this. If I were to stretch my face, my forehead would go up here, my chin would go down there, it would look weird, right? But it's still, oops, I didn't do that very well. It still looks the same. Right? Everyone agree it looks still the same? And that's why I think I actually like this one rather than the base parent function, because I get stretched vertically. Any questions from the class? I am not going to do example B, but I think a lot of you know, just to help everyone out. Example 1B, that's a vertical compression. And so notice what happened to the effects. It was directly related to what happened to that 3. Let's pause here.